Hello and welcome to another GCSE Maths predicted paper walkthrough, and this is the final paper in this 2023 series, which is paper 3, and that's the second calculator exam. Now in this video I'm going to be doing higher tier, but I've also done another video for the foundation tier. Now I've also left a link in the video description which will take you straight to this paper. I've taken it from Maths Genie, so many thanks to them for providing that. And one last thing, I've also added chapter headings to this video. So if there is a particular topic that you're struggling with and you want a bit of work on, then you can just click on that chapter and that will take you straight to that particular question. So with all that out of the way, I think we better get started. So let's get cracking. Question 1, we've got A, which is 2 cubed multiplied by 3 squared multiplied by 5, and B, which is 2 squared multiplied by 3 cubed multiplied by 5. Write down the highest common factor of A and B. So we've been given what A and B are as the product of their prime factors. So I'm just going to write these out again, but I'm going to write them out in full. So we've got A, which is 2 times 2 times 2 times 3 times 3 times 5. And we've got B, which is 2 times 2 times 3 times 3 times 3 times 5. So the highest common factor, what do they both have in common? So we can see that they both have a 2 in common. So I'm going to write 2 down first. They've also got another 2 in common. So they've both got a 2 times 2 in common. Now this one's got a 2, but this one doesn't have a 2. So they've only got 2 times 2 in common. There are no other 2's that they've got in common. So now if we look at the 3's, so we've got a 3 in common for both of them. So we can do 2 times 2 times 3. They've also got another 3. So we can multiply by another 3. They don't have any more 3's in common. But finally, they do have a 5 in common. So this is what they've got in common. They've got a 2 times 2 times 3 times 3 times 5. I could just work this out in my head, but I've got a calculator, so why not use it? So let's just type this into the calculator. 2 times 2 times 3 times 3 times 5. And that gives us 180. So the highest common factor of A and B is 180. Question 2. Verity buys 12 bottles of apple juice for a total cost of £15. She then sells all 12 bottles at £1.75 each bottle. Work out Verity's percentage profit. So to work out percentage profit, let's write down the formula. Percentage profit. Well, we take the actual profit that she's made, so the difference between what she buys them for and what she sells them for, and we divide that by the original cost. And then that will just give us a fraction of the profit, but we want to work out the percentage profit. So all we need to do is just multiply that by 100. So to work out the profit, we just need to work out the difference between what she buys them for and what she sells them for. Well, she buys them for £15, we can see that there. What she sells them for, she sells them at 12 bottles at £1.75 each. So the total amount that she sells them for, we need to multiply. So we're going to do 12 times £1.75. Let's just put that into the calculator. 12 times 1.75, and that is £21. So she sells them for £21 and she buys them for £15. So we just do 21 minus 15, which gives us £6. So now we can put that into our formula. So it's going to be 6 over the original price that she buys them for, which is 15. She buys them for £15. So that will be the profit out of the original, and then as a percentage we just multiply that by 100. So let's type that into the calculator. 6 divided by 15 times 100. And we get exactly 40%. So our answer for this will be 40%. Question 3. The table shows the populations of 5 countries. Work out the difference between the population of India, which we can see is this population here, and the population of Turkey, which is this one here. Give your answer in standard form. So we're just going to subtract one of these from the other. And I can see that India is larger, so I'll do that. I'll take Turkey away from India. So we're going to do 1.4 times 10 to the power 9 and then we're going to subtract 8.4 times 10 to the power 7. And I'm putting it in brackets as well. We don't actually need brackets, I'm thinking, for BidMaths, but I'm just going to use them anyway. So in the calculator, we're going to put 1.4 times 10 to the power of 9, and then close brackets, subtract 8.4 times 10 to the power of 7, and then close brackets. So let me write down the answer in full. Obviously we're going to put this in standard form in a moment. 1316. How many zeros we've got? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we just need to write this in standard form now. So our base number, well, that's going to be 1.316. And we're going to multiply by 10. Let's see how many times. So if I put my decimal point in where we've got it at the moment, 1.316. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be to the power of 9. Part B, given that the population of Iceland is 1 over k multiplied by the population of Denmark. Let's just highlight these populations. We've got Iceland and Denmark. Work out the value of k. Give your answer correct to the nearest whole number. So let's write down the formula again, just down here. So we've got the population of Iceland. We know what that is. So let's write that down. 3.4 times 10 to the power 5. That is equal to 1 over k times the population of Denmark, which is 5.8 times 10 to the power, times 10 to the power 6. And we need to work out the value of k. So first thing I'm going to do is to get rid of k in the denominator, I'm going to multiply both sides by k. So I'm just showing you what I'm doing here. I'm just multiplying both sides by k. So if we do that, on the left hand side, we're going to have 3.4 times 10 to the power 5, all of that times k. And on the right hand side, well, the k's will just cancel out. So all I'm going to be left with is 5.8 times 10 to the power 6. And now to get k on its own, I just need to divide by this whole thing. So let's just bring it up here just so I've got a bit of room. So k is going to be equal to 5.8 times 10 to the power 6, all of that over this here, 3.4 times 10 to the power 5. So now let's put that into the calculator. 3 point, oh no, not 3 point, that's on the denominator. 5.8 times 10 to the power 6 over 3.4 times 10 to the power 5 equals, and we get a very long number here. We need to round our answer, give your answer correct to the nearest whole number. So the nearest whole number, well, that's just going to be 17. So k is going to equal 17. Question 4. The diagram shows the front door, or the front of a wooden door, with a semicircular glass window. Julie wants to apply 2 coats of wood varnish to the front door, shown shaded in the diagram. 250 millilitres of wood varnish covers 4 meters squared of the wood. Work out how many millilitres of wood varnish Julie will need. Give your answer correct to the nearest milliliter. Right, so we need to work out, first of all, let's work out the area of the shaded region. So to work out the area of the shaded region, I think what I'm going to do is calculate the area of the door, sort of the rectangle, and then to just subtract the area of the semicircle. So the area of the rectangle, well, that's just going to be 2 multiplied by 0.75. So that is for, let's just do that. What I'm boxing here is for the rectangle. And then the semicircle, well, it's half a circle. So the formula for a circle is pi r squared. So it's going to be half pi r squared. So we're going to subtract a half times pi times our radius squared. Well, our radius, be careful, it's not 0.5, it's going to be 0.25 because this is our diameter. So 0.25 squared. So that there, that is our semicircle. So let's just pop that into the calculator. So I'm going to put these in brackets because they're separate. So 2 times 0.75 in brackets, subtract in brackets 0.5 times pi times 0.25 squared. You can do this separately. You might want to work out this separately, this one separately, and then subtract one from the other. So that would also be fine. I'm just doing it all in one go. So I'm going to write down everything on my calculator display. So we've got 1.40182523. So that is the area that needs painting. That is the area that needs painting, and that is in meters squared. So let's just make sure we write down our units. That is in meters squared. So now we've worked out the area that needs covering. Let's work out how many milliliters of wood varnish we need. So it says that 4 meters squared, we need 250 milliliters, and we've got 1.4, or not 14, 1.4 meters squared. And the reason I've left a gap is just because instead of going straight from 4 to 1.4, first of all, I'm going to work out what 1 meter squared is, and that's quite easy because I can just divide by 4. So if I do 250 divided by 4, that gives me 62.5. So 62.5 milliliters. And now I can work out what 1.4 is by just multiplying this by 1.4. So times 1.4. And that gives me 87.5 milliliters. So I need 87.5 milliliters of wood varnish to cover the entire door. But remember, we're applying, or Julie's applying, 2 coats. So we just need to multiply that by 2. So times 2, and that gives us 175 milliliters. And we need to give our answer correct to the nearest milliliter. So that is exactly what we're going to write. So our answer is going to be 175. Question 5. A, B, C, D and F, G, H, I are parallel lines. That's these 2 lines here. E, B, G, J and E, H, E, C, H are straight lines. That's these 2 lines. And we're told that BE is equal to CE, which has been given here. These 2 lines are equal. And angle BEC is 48 degrees. So all of this information is provided on the diagram already. Work out the size of angle JGH. JGH is this angle here. That's what we're trying to work out. Give a reason for each stage of your working. So this question is worth 5 marks, and 2 or 3 of those marks are going to come from your reasoning. So make sure that every time you calculate an angle, you give your reasons for why you got that answer. So I'm going to start at the top here, and I can see that we've been given an angle of 48 degrees. These 2 angles are going to be the same because this is an isosceles triangle. So to calculate this angle here, first of all, I'm going to subtract 48 from 180 degrees. That will give me the sum of these 2 angles. And then I'm just going to divide by 2. So this is EBC. So angle EBC is going to be 180 minus 48 and then divide by 2. So let's just pop that into the calculator. 180 minus 48, all of that over 2. And I get 66 degrees. So this angle is 66 degrees, but I can't move on just yet. I need to give my reasoning. So why is this 66 degrees? Well, there's 2 things we said. So first of all, angles in a triangle. Angles in a triangle sum to 180 degrees. And also we said that base angles are equal. So base angles in an isosceles triangle are equal. Okay, and that shows me how I got my 66. Right, so now I've got 66, I can calculate this angle here, and the reason I'm going for this angle is because these 2 angles are related. So this will be angle CBG. So angle CBG. Well, that is going to be, we're going to do 180 minus 66. 180 minus 66. And I think I can do that in my head. That would be 114 degrees. And why did I do 180 minus 66? Well, that's because angles at a point on a straight line sum to 180 degrees. So angles at a point on a straight line, you could probably just get away with saying angles on a straight line, sum to 180 degrees. So we're almost there. We've got one more angle to calculate, and that is the one that we're trying to work out. So that is angle HGJ. So angle HGJ. Actually, I'm just going to write JGH because that's what it's asking for. JGH. Well, that is going to be exactly the same as this angle. So that's also going to be 114 degrees. And the reason I know that is because they are corresponding. So we can say that corresponding, that's a key word there, corresponding angles are equal. Corresponding angles are equal, so our answer is 114 degrees. So notice I've worked out 3 angles and I've given 3 reasons. So you might have worked out different angles to get to your final answer, but as long as you've given valid reasons and you've done everything correctly, you will still get all 5 marks. Question 6. Adam drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. Adam's average speed from Liverpool to Manchester was 80 kilometres per hour, and Adam took 85 minutes to drive from Manchester to Sheffield. Work out Adam's average speed for his total drive from Liverpool to Sheffield. Now, there's a lot of information here, and whenever I've been given a question on distance, speed and time with more than 2 locations, I always like to put the information in a table just because it helps me keep track of everything. So on the top here, I'm going to put where we're going from and to. So the first journey is from Liverpool to Manchester. So I'm just going to put L to M. And then we're going from Manchester to Sheffield. Manchester to Sheffield. And then I'm going to put another column for the total. And then down here, I'm going to put distance, speed and time. So I'm going to put distance. And then I'm going to put the time. And then I'm going to put the speed. The order doesn't really matter. So I'm going to put all of this in a table. And then some of the information we've been given and some of it we'll need to work out. So first of all, what is the question asking us to work out? So it says work out Adam's average speed for the total drive. So the speed for the total drive, that is what we're trying to work out. Now let's put in the information we've been given. Adam drove 56 kilometres from Liverpool to Manchester, so that would be 56 here. 61 kilometres from Manchester to Sheffield, so that will be 61 here. We can work out the total just by summing these together. So if I just write down 56 plus 61, that will give me 117. So the total distance is 117 kilometres. And now let's look at the speed. From Liverpool to Manchester, 80 kilometres per hour. So Liverpool to Manchester, so that will be 80 kilometres per hour in there. Now the time from Manchester to Sheffield is 85 minutes, but be really careful because we're not going to write 85 in wherever it should be, 85 in here, because this is in minutes. Notice our speed for this one is in kilometres per hour. The units need to be consistent. So we need to put the time in hours. So to do that, I'm just going to divide 85 by 60. So 85 divided by 60, because that will convert it into hours. 85 divided by 60. That gives me, or it gives me a decimal, so I'm just going to write it as a fraction, so 17 over 12. 17 over 12. So it might be easier if you want to write it as this, if that makes more sense, but I'm just going to leave it as a fraction. So that will be, or I could write it as a mixed fraction, that's probably more useful. So that would be 1 5/12 of an hour. So which box does that go in? Manchester to Sheffield. So 1 5/12 of an hour. That's the time. So we need to work out I think that's all the information we've been given. So we need to work out the total speed, or the speed for the total journey. So to do that, to work out speed, let's write down our formula. Speed is distance over time. We've already got the distance, but we need to work out the total time. So to work out the total time, we've got the time it takes from Manchester to Sheffield. We need to work out the time it takes to go from Liverpool to Manchester. Oh, I'm supposed to highlight that, not put a line. There we go. We need to work out that one. So we've got the speed for Liverpool to Manchester, and we've got the distance from Liverpool to Manchester. To work out the time, we can just rearrange this formula. So this is going to be time is equal to distance divided by speed. So I'm just going to put this into the calculator. So to do this, I'm going to do 56 divided by 80. So 56 divided by 80. So 56 divided by 80, and that gives me 7 over 10, or 0.7. So 0.7, and remember that is in hours, so that's going to be 0.7 hours. So to work out the total time, we just need to sum them together. So I'm just going to add on 1 and 5/12, or 17 over 12. So 17 over 12. And that gives me this fancy looking number here. So I'm just going to leave it as a fraction again. 127 over 60. So now we've worked out the total time it takes. We've got the total distance. We can now work out the speed. So it's just going to be distance over time. So it's going to be, I haven't got much room here, but 117 over this here, 127 over 60. So that will give me the average speed. So I'm just going to do 117 divided by answer, because it saved the previous answer, and I get this long number here, 55.275. I'm just going to put dot dot dot. Let's have a look. Is it asking us? It's not asking us to round, so it doesn't really. I think what I'm going to do is round to 2 decimal places, so 55.28. Now let's look at part B. It says Bev drove from Reading to Bristol. Bev's average speed from Reading to Swindon was 80 kilometers per hour, and her average speed from Swindon to Bristol was 60 kilometers per hour. Bev says that the average speed from Reading to Bristol can be found by working out the mean of 80 kilometers and 60 kilometers. If Bev is correct, what does this tell you about the 2 parts of the journey? So we're going from Reading to Swindon and then Swindon to Bristol. So there's 2 parts to the journey. The first part, she drove at 80 kilometers per hour. The second part, she drove at 60 kilometers per hour. Now, a big misconception about this is to calculate the mean, we just take the average. Okay, but that wouldn't be correct in most situations. But here, it's saying that if Bev is correct, what does it tell you about the journey? Well, the only situation in which this would be correct would be if the time it takes for both journeys is exactly the same. So if it took the same amount of time from Reading to Swindon and the same amount of time from Swindon to Bristol, then yes, you can just take the mean. But most of the time, for example, in this first part of the question, the times are different, so you can't just take the mean. That's why we had to go through all of this business here. So the 2 parts of the journey must have taken the same amount of time. So let's just write that down. So the time taken for each part of the journey, must be the same, and that will give me my mark. Question 7. A company has to make a large number of boxes. The company has 6 machines. All the machines work at the same rate. When all the machines are working, they can make all the boxes in 9 days. 2 of the machines are not working and cannot be used to make the boxes. Work out the total number of days taken to make all the boxes. So we've got 6 machines. I'm just going to write down here 6 machines. And when they're all working, they can make all the boxes in 9 days. So 6 machines equals 9 days. but 2 of the machines are not working, so we've only got 4 machines. So we've got 4 machines, and we need to work out how many days it takes to make all the boxes. Now, I'm not going to go straight from 6 to 4. I'm going to, first of all, I'm going to work out how long it would take for 1 machine to make the boxes. So if it takes 9 days for 6 machines, well, if we've only got 1 machine, it's going to take longer. A lot of people will accidentally just divide by 6, but it's going to be the opposite way around. Because we've only got 1 machine, it's going to take 6 times as long, because it does say that all the machines work at the same rate. So it's going to take 6 times as long, so I'm going to multiply this by 6. So now it's going to take 54 days for 1 machine. So now if you think about 4 machines, well, it's going to be quicker, and it's going to be 4 times quicker. So now I'm going to divide by 4. So for this, I'm going to put it into the calculator because I'm not going to get a nice integer answer. So 54 divided by 4 gives me 13.5. So 13.5 days, I think 4 machines. So that is my answer, 13.5 days. Question 8. Janet bought a new car 3 years ago. At the end of the first year, the value of the car had decreased by 17.5%. The value of the car decreased by 10% each year for the next 2 years. At the end of the 3 years, the car was worth £16,038. Work out the value of the car when Janet bought it 3 years ago. So for this question, we're going to be working backwards to work out the original value. So let's just say the original value was X. Well, at the end of the first year, the value of the car is decreasing by 17.5%. So we're starting off at 100% and we're going to subtract 17.5%. So 100 minus 17.5%. That gives us 82.5%. So now our car is worth 82.5% of our original value. So our multiplier will be 0.825. So we're going to multiply that by 0.825. And then the car is decreasing by another 10% each year for the next 2 years. So here our multiplier is going to be 0.9 because it's going to be 90% of the previous value. So we're going to multiply by 0.9 and then multiply by 0.9 again. And we can see that our answer after 3 years, well, that's going to be £16,038. So we want to work out what X is. So to get X on its own, we're just going to divide by all of this. So X is going to equal 16,038 divided by all of this. So 0.825 times 0.9 times 0.9. So if I just put that into the calculator, so 16,038 divided by 0.825 times 0.9, I could just put 0.9 squared, and that gives us 24,000. So that's always a nice answer to get with these sort of questions. So our answer for this one is £24,000. A lot of people make mistakes on reverse percentages, and they will just take this number and multiply it by 0.825 times 0.9 times 0.9. But we're working backwards, so we have to do the opposite. Question 9. Simplify fully this expression here. So whenever we're raising something to a negative power, we just need to flip the fraction and raise that to the positive power. So instead of writing it like this, I'm going to flip the fraction. So 9y to the power 10, all of that over 16x to the power 4. And then all of that is going to be raised to the positive a half power. So when we're raising a fraction to a power, that means that both the numerator and the denominator are being raised to that power. So the numerator is going to be 9y to the power 10 to the power half, and the denominator is going to be 16x to the power 4 to the power half. I'm trying to show every step here. So now let's first of all deal with the numerator. So what we've got here, 9y to the power 10, all of that is being raised to the power half. So we're going to do 9 to the power half. Well, that's just the square root of 9, which is 3. And then we're going to do y to the power 10 to the power half. Now, whenever we're raising a power to a further power, we multiply the indices. So it's going to be y to the power of 10 times a half, which is just 5. So this is our numerator. And then in our denominator, again, we're going to take the square root of 16. Well, that's just 4. And then we're going to multiply our indices. So it's going to be x to the power of 4 times a half, which is 2. And I don't think we can simplify that anymore because we've got different variables in the numerator and denominator. So that is our answer. So we've got 3y to the power 5, all of that over 4x squared. Question 10. Expand and simplify this set of triple brackets. Now I like triple brackets because I like drawing out the grids. So first of all, I'm going to expand out these set of brackets, and then when I've done that, I'm going to expand out that with this last bracket here. So I always like to use the grid method, especially when I've got triple brackets. So some of you might be using FOIL, but I'm going to use the grid. So we've got 2 minus x, and then we're multiplying that by 2x plus 3. So if I just draw in my grid, I'll try and do it as neat as I can. Oh, that was a bit wonky. It doesn't really matter. So 2x times 2, well, that's 4x. 2x times negative x, that's negative 2x squared. 3 times 2 is 6. 3 times negative x is negative 3x. So what's this going to give me? This is going to give me 4x minus 2x squared plus 6 minus 3x. I've just written down all of those terms, but we can simplify. So I'm just going to write the x squared term first. We've got negative 2x squared, and then 4x minus 3x, that's just 1x, so plus x, and then plus 6. So this is our expression when we multiply out what's in red, and now we just need to multiply that by x plus 4. X plus 4. Now we're just going to focus on this part here. And again, I'm going to use the grid. So let's first do this part. So we've got minus 2x squared, and then we've just got plus x and plus 6. And down here we've got x plus 4. Now we should have 6 terms. So this is one of the reasons why I use the grid method, is because I know that I'm going to be left with 6 terms. If you use the FOIL method, sometimes you might be, you might forget to multiply some things together and you might end up with 5 terms. So I think this just helps me organise everything. So x times negative 2x squared, well, that's negative 2x cubed. X times x is x squared. 6 times x is 6x. Negative 2x squared times 4, that's negative 8x squared. 4 times x is 4x. 4 times 6 is 24. So first of all, let's write down all of the terms we've got. We've got negative 2x cubed plus x squared plus 6x plus negative 8x squared plus 4x plus 24. But we can simplify. So we don't have any other x cubed terms, so we're going to have negative 2x cubed, but we do have 2x squared terms. We've got 1x squared minus 8x squared. That's going to give us minus 7x squared. Minus 7x squared. Now let's look at our x terms. We've got positive 6x and positive 4x. That's going to give us positive 10x. And then we've got that 24 hanging out the back there. So plus 24. So that is my final answer. Question 11. The box plot shows information about the distribution of the amounts of money spent by some male students on their holiday. Part A, work out the interquartile range for the amounts of money spent by these male students. So to work out the interquartile range, so the IQR, we take the upper quartile and we subtract the lower quartile. So the upper quartile will be this part here. So that is the upper quartile. So we just need to work out what value it is. Now the graph is quite small, but I can see this is 300, this is 400. There seems to be 5 squares between these two values. So each square must be £20. So if I just go up to here, that's 300. So that will be 320. So it's going to be between 320 and 340. I'm just assuming that's halfway. So I'm going to say that's 330. So the upper quartile will be 330. The lower quartile, well, if this is 200, that's 180, 160, 150. So that'd be £150. So 330 minus 150. I don't need a calculator for that. I can see that as be £180. So that is my interquartile range. Now let's look at part B. The table below shows some information about the distribution of the amount of money spent by some female students on their holidays. So we're going to be comparing males and females. On the grid, draw a box plot for the information in the table. Okay, so what have we got? We've got the smallest value is 60. So 60 is, let's do it down here to give ourselves a bit of room. So 0, 20, 40, 60. Actually, let me get my line tool out, be a bit more accurate. 0, 20, 40, 60. So that is 60. See, the lowest is higher than the boys. Now let's look at the lower quartile. That's 180. So if that's 200, 180 is going to be here. There we go. And then the median is 300. That's bang on this point here. And then we've got the upper quartile, 350. So 300, 320, 340, 350. This isn't perfect. You can see, oh, let me do that one again. That's not quite right. 330, 350, sorry. There we go. Again, not perfect. And the highest is 650. Hopefully you get the idea here. So 600, 620, 640. So 650 will be here. There we go. So we've got all of our points. Now we just need to draw the box. So the box, we connect the two quartiles together. Like so. And then we need the whiskers. You might have had this as a box of whiskers before. We just need to draw the whiskers on. There we go. And finally, there we go. So we have drawn our box and whiskers plot. So that is worth 2 marks. Now let's look at part C. So it says, Chris says the box plot shows that the female students spent more money than the male students. Is Chris correct? Give a reason for your answer. Right, let's have a look. So he says that the female students spent more money than the male students. So this is female, this is male. So usually when we're comparing distributions and looking at which ones spent more or which value is higher than the other, we tend to look at the median. So I can see that if we're looking at the median is indeed higher for the females compared to the males. So I'm going to say that Chris is correct. So I'm going to say yes. Give a reason for your answer. We can say the median for the girls is higher than the boys. And I'm just going to put in brackets what the values are. So that was 300. £300 is greater than whatever the boys is, which was, that's 200, 220, 240, 250. £250. So here I'm using the median because that's the best estimate to use for working out which one on average is higher. Obviously the highest male student spent more than the highest female student, but overall as a group we should use the median. Question 12. Using algebra, show that the recurring decimal, which is this decimal here, is equal to this fraction. Now these questions don't tend to come up on calculator exams because you could just put this into a calculator and it will give you this fraction, but we can't do that. We have to use algebra to work out this question. So let me just write down what number we've got. 0.1803, and it's the 0 and 3 that recur. So it's going to be 0, 3, 0, 3, ... So what I'm going to do is I'm going to set that equal to x. Now, because we've got 2 digits that recur, I'm going to multiply it by 100. So if there was only one digit that recurs, I would have multiplied by 10. 2 digits, I'd multiply by 100, and if there were 3 digits, I'd multiply by 1,000. So I'm going to multiply both sides by 100, and you'll see why I'm going to do this in a moment. So if I multiply the left-hand side by 100, I get 100x. And if I multiply the right-hand side by 100, well, the decimal point is going to move 2 places to the right, so it's going to be 18.03 recurring. So 18.03030303 ... So now you can see, hopefully, why I multiplied by 100, and that's so that these digits line up with one another. So now I can subtract one equation from the other, and notice the 3's will cancel, these 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 will cancel, and now all I'm left with is 100x. Sorry, all I'm left with is 18.03 minus 0.18. And to do that, I think I'm just going to use the calculator. So 18.03 minus 0.18, and that gives me 17.85. So on the right hand side we've got 17.85, and on the left hand side we've got 99x. So we want to work out what x is, so just going to divide both sides by 99, so we get x is equal to 17.85 over 99. We obviously can't leave it like this. We can't have a decimal in a fraction, so to get rid of this decimal I'm just going to multiply top and bottom by 100. So that gives me 1785 over 9990, and we just need to prove that this is the same as this. Well, we can just simplify this, and to simplify it I'm just going to use the calculator. So we've got 1785 over 9900, and yes, hey presto, we have the same answer. So we can just simplify that, 119 over 660. So we have used algebra to show that 0.1803 recurring is equal to this fraction. Question 13. Saffron wants to work out an estimate for the total number of fish in a lake. On Friday, Saffron catches 200 fish in the lake, 200 fish from the lake. She puts a tag on each of these fish and puts them back in the lake. She puts those fish back in the lake. On Saturday, Saffron catches 240 fish from the same lake, and she finds that 35 of the 240 fish are tagged. Work out an estimate for the total number of fish in the lake. Now, these types of questions can be a little tricky to work your way around. So if we just start from the top, it says, on Friday, Saffron catches 210 fish from the lake. So she catches 210 fish out of the total number of fish in the lake, which we don't know. So let's just call that X. Now she puts a tag on each of these fish and puts them back in the lake. So all of these 210 fishes she tags and puts them back in the lake. And then on Saturday, she catches 240 fish this time from the same lake, and 35 of those are tagged. So obviously not all of the ones that she tagged she's pulled out. She's pulled out 35 of them that are tagged out of 240. Now, the key thing to recognise is that these two fractions are equal. Okay, the proportions should be the same. So what she picked out the first time should be the same as what she picked out the second time, because it's just sort of a random pick of fish from the lake. So they should be the same. So we can use this information now to work out this missing value for x. So to go from sort of 35 to 210, what did we do? Well, let's just type that into the calculator. 210 divided by 35 is 6. So we just multiplied by 6. So if we just do exactly the same with the denominator, if we times that by 6, 240 times 6, we get 1,440. So an estimate for the total number of fish in the lake is 1,440. So obviously we're not saying that this is exactly the number of fish in the lake, it's just an estimate. Now, if you didn't quite understand my workings out here, let me pop this number that I got back into my original equation, and hopefully that will make sense. So we've got 1,440 fish in the lake, and 210 of them are tagged. Now, if you were to take another sample of fish from the lake, the proportion that are tagged should be exactly the same as this proportion here. So now if she's only taken 240, then only 35 of them will be tagged. So hopefully you can see why these two fractions should be equivalent fractions. And another way of thinking about it is that this here, well, this is just a sample. So if this is a sample of the whole population, you would expect the proportions to be the same. Question 14. P, Q, R and S are 4 points on a circle, centre X. PXR and SXQ are straight lines. Prove that triangle PQX and triangle SRX are congruent. So we need to prove that these two triangles are congruent. Now, whenever we're proving things are congruent, we need to give reasons. So that's really important for this type of question. So first of all, I can see that this angle here and this angle here, well, they're both equal because they're opposite angles. So I can say that PXQ, so angle PXQ is equal to angle SXR. And for each statement I make, I have to give a reason. So I'm just going to put that in brackets. So opposite angles are equal. So opposite angles are equal. Okay, what else is the same? Well, now I'm going to look at some side lengths, and I'm going to say that this side length here is equal to this side length. And the reason I know that is because they're both radii. So this is a radius of the circle, and this is a radius of the circle. So whatever direction they go in, they're always going to be the same length. So I can say that SX is equal to PX. And the reason for that is that they are both radii. Okay, and I can do exactly the same for these two. So this side length is equal to this side length, and for exactly the same reason. So QX is equal to RX. And again, we can say that they are both radii. Now, do we have enough information to say that these two triangles are congruent? Well, yes, we do. So we can say that they're congruent through SAS. So side, angle, side, side, angle, side. So we can say that triangle PQX is equal to, or congruent to, I think that's the symbol for congruent. You can just write congruent. So triangle SRX by SAS. So you don't need to write side, angle, side. I've just put SAS for short. So you give your three statements, your three reasons, and just a concluding statement to show that those two triangles are congruent. And obviously this isn't the only way of answering this question. So for example, I can see that this angle here is equal to this angle. So let me just do two lines to show they're different from these ones here. So these two angles are equal, and we can use our circle theorems to say that angles in the same segment are equal. So there's more than one way of answering this question. This is just the sort of method that I've decided to use. Question 15. Here is a speed time graph for a train. Part A, work out an estimate for the distance the train travelled in the first 20 seconds. Use 4 strips of equal width. So to calculate the distance on a speed time graph, we're calculating the area underneath the curve. Now, we're not calculating the whole area. We're only interested in the first 20 seconds, and we have to use 4 strips of equal width. So we're clearly just going to use 5-second strips here. So we're only calculating an estimate. So what I'm going to do is, let me get my line tool out. The first part we're going to do, let's do 0 to 5. I'm going to draw in a triangle. Okay, so I'm going to draw in a triangle. Just like that. You can see that is a pretty good estimation. It's not exactly going to be the area, but it's close enough. So let's calculate the area of this triangle. So I'm just going to put 0 to 5 seconds. So it's going to be a half times the base times the height. So a half times 5 times the height. Now we just need to work out what the height is. So we've got 10 squares here. And 5 meters per second. So each square will be 0.5 meters per second. So it's going to be 0.5, 1, 1.5, 2. So that's 2 meters per second. So times 2. So I can do that in my head. 10 divided by 2 is 5. So that's going to be 5, and our units will be in meters. So that's 5. Let me just write it in here. 5. Now let's work out 5 to 10. And for this, I'm going to use a trapezium. So I'm going to draw my line up there. And then I'm going to connect these two together. And you can see we've got a nice trapezium there. So if we just think back to how we calculate the area of a trapezium. So we've got 5 to 10. So to calculate the area of the trapezium, we sum the parallel sides. And then we divide by 2 and then times by the height. So we're going to add together the parallel sides first. So it's going to be 2. This here is 2. Plus this here, which is bang on 5. So 2 plus 5, divide that by 2, and then times by the height. Well, the height is sort of the width in this case, because the trapezium is turned on its side. So times by 5. So that's 7 divided by 2. Let me just get the calculator out. So 7 divided by 2, and then times by 5. We get 17.5. 17.5 meters. So let's pop that in here, 17.5. Now let's carry on. So this question does take a bit of time, but it's worth doing it correctly. So now we're going to do another trapezium. So up to here, and then draw a line from here to here. And you can see now we're starting to sort of make a bit of an error in, obviously we're only doing an estimate, but you can see this slither that we've got that we're accounting for that we shouldn't account for. So we'll come to that in the second part of the question. But right, so we're doing 10 to 15 now. So the formula exactly the same. So we're going to sum the parallel sides. So it's going to be 5 plus this point here, which is 10, divided by 2 times 5. So that's 15 divided by 2. 15 divided by 2 times 5, and we get 37.5 meters. So 37.5, and finally let's just do the last one. So all the way up to that point there. You do need to be very accurate on this. My graph is a bit smaller than yours. Oh, I'm definitely not drawing it in. I'm going to use my line tool again. So we're going up to there. There we go. Right, so exactly the same formula for 15 to 20. So it's going to be this point, which is 10, plus this point. This is, well, that's 17.5. That'll be 18. And then divide by 2. I'm running out of room here. Times by 5. So this is 28 divided by 2. That's 14. 14 times 5 is 70. Yeah, 70 meters. So 70. So we just need to sum these together. So we're going to do 5 plus 17.5 plus 37.5 plus 70. So let's just add on 70 plus 17.5 plus 5. And we get 130 meters. So we only need to put 130 in here. So that is our answer. That is our estimate for the total distance travelled in the first 20 seconds. Now let's look at part B. Is your answer to A an underestimate or an overestimate of the actual distance of the train travelled? Give a reason for your answer. Now I've mentioned before these slithers that we accounted for. So when we calculated the distance, we included, let me just do it in a different colour, in red, we included this information here that we shouldn't have. So this information here we accounted for, but we shouldn't have accounted for it. So the real distance will actually be less. Okay, so we've calculated more than we needed to. So is your answer an underestimate or an overestimate? We have overestimated. So overestimate of the actual distance. Give a reason for your answer. So we can say overestimate because we calculated, we can say the extra area above the curve. The extra area above the curve. So something like that. Obviously it doesn't need to be word for word, just showing that we've calculated area that we shouldn't have calculated. Question 16. Using algebra, prove that given any 3 consecutive even numbers, the difference between the square of the largest number and the square of the smallest number is always 8 times the middle number. So this sounds very complicated and there's a lot going on here, but if we just take it one step at a time. So first of all, 3 consecutive even numbers. Well, to be an even number, it needs to be a multiple of 2. So we can say that 2a, that is an even number. It doesn't matter what a is. A could be 17, but if we multiply it by 2, it's now going to be even. So that's one even number. But we're looking for 3 consecutive even numbers. So the next even number after this must be 2a plus 2. And then the next even number after that would be 2a plus 4, 2a plus 6, etc. So these are our 3 consecutive numbers. And we need to look at the difference between the square of the largest number and the square of the smallest number. So the square of the largest number will be this squared. So it will be 2a plus 4 squared. And we need to subtract the square of the smallest number, which is 2a. So in brackets 2a squared. And we need to, that should be equal to 8 times the middle number. So let's just work out what this is first. So I'm just going to do this in double brackets, just so I'm showing you every step I'm doing. So 2a plus 4 squared is 2a plus 4 times 2a plus 4. Subtract 2a squared, well that's 2 squared is 4, and a squared is just a squared. So let's expand these double brackets. 2a times 2a is 4a squared. 2a times 4 is 8a. And we've got another 8a here. And then 4 times 4 is 16. Plus 16. And then we're subtracting 4a squared. Now we can do a bit of simplification here. 4a squared minus 4a squared. Those two terms will cancel out. And all we're left with is 8a plus 8a, which is 16a. And then we've just got that plus 16. So we've worked out what we can't simplify this anymore. We've worked out this part. Now we need to prove that this is equal to 8 times the middle number. So let's do that over here in a different colour. So 8 times the middle number. Well, the middle number is 2a plus 2. So if we just expand these brackets, 8 times 2a, that's 16a. And then 8 times 2 is 16. And look at that. Hey presto, these two things are the same. So we can say that I'm just going to draw an arrow and I'm just going to write same here. So we've proved that the difference between the squares of the largest and smallest numbers is 16a plus 16, and 8 times the middle number is also 16a plus 16. So we have answered that question perfectly fine. Question 17. The straight line L passes through the points 4, -2 and 6, 5. The straight line M is perpendicular to L and intersects the y-axis at 0, 3. Find the coordinates of the point where M intersects the x-axis. So we've been given the straight line, the coordinates of L. So we can work out the gradient of L. So let's write this down. Gradient of L. Well, to work out the gradient, we do change in y over change in x. So what is the change in y? Well, we're going from 5 and we're going to subtract -2. So 5 minus -2. And then we've got 6 minus 4. Obviously, make sure you're dealing with the negatives correctly here. So 5 subtract -2, well, that will give us 7. 6 subtract 4 is 2, so our gradient is 7 over 2. Now we're told that M is perpendicular to L. So we can work out the gradient of M. Gradient of M. And that's just going, because it's perpendicular, it's going to be the negative reciprocal of L. So we flip it upside down and we take the negative. So it's going to be negative 2 over 7. So that's the gradient of M. And now we're given one of the points of M, because it says it intersects the y-axis at the point 0, 3. So we can write down the equation of this line now. So the general equation of a line is y equals mx plus c, where m is the gradient and c is the y-intercept. But we know both of these values. We know what the gradient is, and we also know what the y-intercept is. So the gradient, the equation of m is going to be y is equal to negative 2/7 x plus 3, because our y-intercept is 3, plus 3. So now we've got the equation for m, and it's asking us to find the coordinates of the point where m intersects the x-axis. So if it's intercepting the x-axis, the y value must be 0. So I'm just going to put 0 into this equation now and solve for what x is. So we've got 0 equals negative 2/7 x plus 3. So the first thing I'm going to do, I think, is I'm going to add 2/7 x to both sides, just so I've got this as positive. So we're going to have 2/7 x is equal to 3. And now to get x on its own, I'm just going to multiply by 7 over 2, just the reciprocal. So x is going to be equal to 3 times 7 over 2, which is equal to 21 over 2. So I found my value for x. So find the coordinates of the point where m intersects the x-axis. Well, it's going to be 21 over 2, and our y value will be 0. You can write 10.5, but I've just left it as a fraction. Question 18. Show that this expression here can be written in this form where a and b are integers. So the key thing to remember when you're adding and subtracting fractions is the denominators have to be the same. So to make the denominators the same, I'm going to multiply this fraction by x minus 3 over x minus 3, and I'm going to multiply this fraction by x plus 3 over x plus 3. So let's do that. So we've got x over, and I'm just going to leave a space, so x plus 3. So I'm going to multiply this fraction by x minus 3 over x minus 3. And now if we look at the second fraction, we're subtracting 2x minus 1. Again, I'm just going to extend the line. So here we've got x minus 3. And I'm going to multiply this fraction by x plus 3 over x plus 3. Okay, and it doesn't matter that I'm doing this because I'm not changing the value of the fraction, because essentially I'm just multiplying by 1. But now you can see that our denominators are the same. And I'm going to do exactly the same for 1. So plus, instead of writing 1, I'm going to write x minus 3 times x plus 3. All of that over x minus 3 times x plus 3. Hopefully you can see that this is just 1. This is exactly the same as 1 because we're dividing something by itself. So now we've got the same denominators, we can just add the numerators together. So we've got, I'll do it in steps. So we've got x times x minus 3 minus 2x minus 1 times x plus 3. And remember, we're subtracting this whole thing. So I'm just going to put this whole thing in brackets because we're subtracting this whole expression here. And then we're going to add on x minus 3 times x plus 3. And this whole thing is being divided by x minus 3 times x plus 3. So we've got quite a big fraction here. So let's go through each of these terms. So first of all, if we expand these brackets, we've got x squared minus 3x. And now we're subtracting this whole thing here. So again, I'm going to leave the brackets in. So we've got, let me just put these in brackets. I forgot to put these in brackets. So we've got double brackets here. So 2x times x, that's 2x squared. 2x times 3, that's plus 6x. And then we've got negative 1 times x, that's negative x. And negative 1 times 3 is negative 3. So we're subtracting this whole thing. And then we're adding on this whole thing up here. So if I expand these brackets, we've got x squared plus 3x minus 3x minus 9. And then all of that, again, that whole thing is over x minus 3 times x plus 3. I'm running out of room. Hopefully I'll be okay. So let's do the numerator. So we've got x squared minus 3x, and now we're subtracting 2x squared. We're subtracting 6x. We're subtracting negative x. So that's actually going to be plus x. And also we're subtracting negative 3, so that's going to be plus 3. And then we're adding on x squared. These two terms will just cancel out with each other. And then we're just subtracting 9. And again, all of that is over x minus 3, x plus 3. And at this stage, I'm just noticing, looking at the answer, it wants it like this. If I expand this out, that will give me x squared minus 9. Because this is exactly the same as this bit here. So I can just write in x squared minus 9. And now I think I just need to simplify the numerator. So we've got x squared plus x squared. So x squared plus x squared. That gives me 2x squared. But then we're subtracting 2x squared. So all these three terms will just cancel out with one another. Now let's look at the x terms. We've got minus 3x, minus 6x, and plus x. So that will give us minus 9x, and then if we add x, we've got minus 8x. So minus 8x. And now let's just deal with the constant terms. We've got plus 3, minus 9, that's minus 6. So we've got minus 6, and then all of that is over x squared minus 9. And we can't simplify this anymore, so let's just check with our answer. So a is negative 8, b is negative 6, and we've got the same denominator. So this is written in this form. Question 19. Express 9 plus 8x minus 2x squared in this form, where a, b, and c are integers. So it looks like we're going to need to complete the square because we've got here something in brackets all being squared. Now, whenever we're completing the square, first I like to put my x squared terms first, then my x terms, then my numbers. So I'm just going to rearrange this and put negative 2x squared plus 8x plus 9. So all I've done is I've just moved some things about. Now, whenever we're completing the square, we have to complete the square on x squared. There shouldn't be any coefficient on the x squared term. So what I'm going to do is I'm just going to factor out a negative 2 from this part of my expression. So if I factor out a negative 2, what am I going to be left with? Well, I've got x squared minus 4x. So what I've just done here is this bit that I've put in brackets is exactly the same as this. I've just factored out a negative 2, and then we've got plus 9. And now we can complete the square. So we've got negative 2, and then x squared minus 4x. I'm just going to leave a space so that I can complete the square, and then put plus 9. So now, what number do I need to put in here in order to complete the square? Well, to do that, what I do is I half the coefficient on the x term and then square it. So half of negative 4 is negative 2. Negative 2 squared is 4. So I'm going to add on 4. I'm going to add on 4, and now this is in, I can factorize this. I can complete the square. So if I'm adding on 4 here, be really careful now, because I'm not adding on 4. Although I've written down plus 4, notice that I factored out a negative 2. So if I were to expand the brackets, this would actually be minus 8. So what I'm doing by putting this in here, I'm subtracting 8, because negative 2 times 4 is minus 8. So if I'm subtracting 8, in order to keep the expression the same, I also have to add on 8. So that bit here is where a lot of people go wrong. They'll put +4 here and -4, which isn't correct in this case because we've actually factored out a -2. So this bit here can be factorised. This bit here, so this is just x minus 2 squared. So we've got -2, x minus 2, all of that squared, and then 9 plus 8 is 17, so plus 17. So we've pretty much got it in this form. We just need to put everything back how it was because we switched it at the beginning. So a is 17, so it's going to be 17, and then we've got all of this business here. So we've got -2 times x minus 2, all of that squared. So you can see that a is equal to 17, b is equal to -2, and c is equal to -2 also. You don't have to write all of this in. I'm just showing you how it matches up to what they're asking for. Part B. C is the curve with equation y equals 9 plus 8x minus 2x squared, which is exactly the same equation up here. The point A is the maximum point on C. Use your answer to part A to write down the coordinates of A. So to work out the maximum or minimum points, we can just use our completed square form here. So I'm going to use this one. I always find this a bit easier to use. So our x value, well, our x value is just going to be the opposite of the number we've got in here. So that's just going to be 2. Oh, using the wrong pen there. Should be using my pencil. So that's 2. And the y value, well, that's just going to be this number here, which is 17. So that is our maximum point. So you can see how that when we've got something in completed square form, it's really easy to pick out what the minimum and maximum points are. Question 20. Triangle A is transformed by the combined transformation of a reflection in the x-axis, followed by a reflection in the line x equals -2, followed by a translation with vector -4, 2. So we've actually got 3 transformations that we're going to have to perform. One point on triangle A is invariant under the combined transformation. Find the coordinates of this point. You must show your working. So first of all, what does the word invariant mean? Well, the word invariant just means it does not vary or does not move. Does not move. So after we've performed all 3 transformations, there will be one point on our triangle that is still in exactly the same place that it started with. So that's what we need to work out. So let's do each transformation in turn. So first of all, we're starting off with a reflection in the x-axis. So we're going to reflect each point in the x-axis. So this point is going to be here. Let's just color coordinate this. This point is going to be here. And finally, let's use fuchsia. This point is going to be down here. So I think what I'm going to do is now let's just draw in our triangle. So just because I think it will be easier if we can actually see the shape after each transformation that we've done. There we go. So that is our first transformation. Our second transformation, we are reflecting the shape in the line x equals -2. So actually, let me draw in the line x equals -2. That is this line here. That is the line x equals -2. Be really careful. It's not a horizontal line. It's a vertical line. So now let's transform each vertex. So this blue one here will now be over here. The red one will be over here. And the fuchsia coloured one, that will be down here. And once again, let's draw in our shape. If you want to skip along, feel free to do that. I'm not going to edit this part of the video. I'm just going to keep it as it is. Right, okay, and then the last point will come up to here. Okay, so we've done 2 transformations. Now let's do the last one. So we need to do a translation with vector -4, 2. So a translation, that just means move. So let's first of all start off by moving the blue point. So -4, 2. So 1, 2, 3, 4, 1, 2. Now the blue point is here. Let's do the red point. So the red point 1, 2, 3, 4, 1, 2. Oh, that's interesting. And now the fuchsia point. 1, 2, 3, 4, 1, 2 there. And you've probably already spotted what I've spotted. Let's just draw it in anyway. This is our new shape, our new triangle. Let's just fill that in. There we go, just for completeness. Now, notice the red point. Something fancy happened with the red point, and that is it went back to its original position. So we know the red point is the one that is invariant, this red point here. So what are the coordinates of that point? Let me just get my pencil back out. So the coordinates of this point are -4, comma 1. So -4, comma 1. Question 21. Prove algebraically that the straight line with this equation is a tangent to the circle with this equation here. Now, you might be tempted to start drawing some axes and some circles, but this question is actually about solving simultaneous equations. And the reason I know that is because of this keyword here, tangent. So if a line is a tangent to a circle, it means it only touches that circle at exactly one place. So if we were to solve this pair of simultaneous equations and we only have one solution, well, that must mean that the line must be a tangent to the circle. So let's have a go at solving this pair of simultaneous equations. We've got one quadratic and one linear. So whenever you're solving a pair of equations where you've got one of each, what you should do is you should substitute the linear equation into the quadratic equation. So the first thing I'm going to do is I'm going to rearrange this equation to make y the subject. So we've got 2x plus y plus 5 is equal to 0. So I want to get y on its own. So I'm going to subtract 2x from both sides and I'm going to subtract 5 from both sides. So I'll be left with y is equal to -2x minus 5. So now I've made y the subject, I can substitute this expression for y into my quadratic equation. So let's do that. So we've got x squared plus y squared. So instead of writing y, I'm going to write -2x minus 5, all of that squared, and that equals 5. So our next line of working, we've got x squared. Now I'm going to just write out the double bracket, so just do it in full first. So we've got plus -2x minus 5 times -2x minus 5, and that equals 5. So now I can expand these brackets. So we've got x squared. Now we've got -2x times -2x, that's positive 4x squared. Then we've got -2x times -5, that's also positive, so that's plus 10x. This will also be plus 10x in the middle. And then -5 times -5 is plus 25. And we're going to have 0 on the right hand side, so I'm just going to subtract 5 from both sides. So minus 5 equals 0. Now I can just tidy this up now. So x squared plus 4x squared, that will give me 5x squared. 10x plus 10x, that's plus 20x. And then 25 minus 5 is plus 20. That equals 0. And now everything here is divisible by 5. So I can divide everything by 5. I'll be left with x squared plus 4x plus 4 equals 0. Now this expression here factors very nicely indeed. So if we were to factorize this, we will get x plus 2 squared. So x plus 2 in brackets, all of that squared. And if you don't believe me, you can expand this out. That equals 0. Now to solve this, if I square root both sides, I'll have x plus 2 equals, well, the square root of 0 is just 0. We don't need to write plus or minus 0 here. So that's fine like that. And now just to get x on its own, if we subtract 2 from both sides, we get x is equal to -2. So we do only have one solution. X is going to equal -2, and y, let's do y up here. Well, y is going to be -2 times x. Well, x is -2. And then minus 5. So negative 2 times negative 2, that's positive 4. So it's going to be 4 minus 5, which equals negative 1. So our solution is x equals negative 2, or the coordinates of our point of intersection are negative 2, negative 1. So we have proved that the line is a tangent to the circle because there is only one point of intersection. It only touches the circle at exactly one point. So if we just write a concluding statement and say that the line is a tangent because it touches the circle, at exactly one place. And if I just give the coordinates of that place, that's negative 2, negative 1. And we are done. Question 22. The diagram shows two circles such that the region R, shown shaded in the diagram, so this region here, is the region common to both circles. One of the circles has centre O and radius of 5 centimetres, and the other circle has centre P and radius of 4 centimetres. An angle AOB is 50 degrees. So all of this information has already been given to us in this text here. Well, it's been given to us on the diagram. We need to calculate the area of region R. So we need to calculate this area here. Give your answer correct to 3 significant figures. Now I'm just looking at the marks, and it's worth 6 marks. So it will take quite a long time for this question, but hopefully it will be worth it in the end. So the first thing I'm thinking of doing is just adding a bit more information to the diagram. So I can see that the radius is 4 centimetres. So I'm just going to write on here 4, and I'm going to write on here 5, just because I think it will help me out a bit. Now we need to calculate this area here. Now this is quite an unusual shape, but what I can do is I can cut it in half. So if I draw a line from B to A, now this shape here, we've got two segments of a circle of 2 different circles, and we can calculate the area of segments. So the first one I think I'm going to look at is this area here that I'm shading in red. So to calculate the area of a segment, let's write this down. So area of a segment, that's going to be equal to the area of the sector. So this whole sector will be the area of the sector, subtract the area of this triangle. So notice if I take the sector, take away the triangle, I'm left with this slither of a segment. So take away the triangle. Now with this information, we should be able to get everything. So let's first of all work out the area of the sector. So what we do is we take the fraction of the circle and then just multiply by the area of a circle. So it's going to be 50 over 360, and then we're going to multiply that by pi r squared. So pi times our radius squared, 5 squared. Okay, let's see what that is. So let's get our calculator out. 50 over 360 times pi times 5 squared. And we get 125 over 36 pi. Now let's do the same for the triangle. So I think I'll do this in blue just to change it up a bit. So the area of a triangle, we can use the sine rule for areas of triangles. So the sine rule says is half AB sine C. So it's going to be a half times 5 times 5 times the sine of 50 degrees. So what does that give us? So let's type it all in. 0.5 times 5 times 5 times the sine of 50 degrees. Lots of 5s in there. And we get 9.575. I'm just going to put ... because that just keeps going on. So the segment, we're just going to take one away from the other. So I've already got this saved in my calculator. So I'm just going to put, so segment equals 125 over 36 pi. Then I'm just going to subtract answer because it's already saved. This number's already saved. And I get 1.33. We'll need to round to 3 significant figures in the end. So I'm just going to round it to 3 decimal places. 333. So that is going to be in centimetres squared. So that is the area of the red segment. Now let's calculate the area of the purple segment. So here, this segment here. Now it's going to be a bit trickier than before because notice we don't have this angle. So the first thing we're going to have to do is try and work out what this angle is here. So at the moment we don't have enough information, but if we calculate the length of AB, then we'll have this length, this length, this length, this length, and this length. We can use the cosine rule to calculate the angle. So I'm going to calculate length AB. And to do that, I'm also going to use the cosine rule. So the cosine rule is A squared equals B squared plus C squared. Let me write it down actually. So cosine rule is A squared is equal to B squared plus C squared minus 2BC times the cosine of A. And we have all of the information we need. So it's going to be 5 squared plus 5 squared minus 2 times 5 times 5 times the cosine of 50 degrees. So A squared. So remember this is A squared. So 5 squared plus 5 squared minus 2 times 5 times 5 times the cosine of 50 degrees. Right, so we get 17.860 ... So therefore A, we just need to take the square root answer, and we get 4.226. 226 ... So now we've calculated AB. We've got all 3 side lengths. We can use the cosine rule again, but this time it's for the angle, not a side length. So I'm just going to rearrange this formula to put it in terms of the cosine of A. You may already know the formula off by heart. Unfortunately, I don't. I always have to rearrange. So that's what I'll do. So let me just write out the cosine rule again down here. We've got A squared is equal to B squared plus C squared minus 2BC cos A. Now the first thing I'm going to do is just add 2BC cos A to both sides. So we'll have A squared plus 2BC cos A equals B squared plus C squared. And now I'm going to subtract A squared from both sides. So we've got 2BC cos A is equal to B squared plus C squared minus A squared. And now the final step is just to divide both sides by 2BC. So we've got cos of A is equal to B squared plus C squared minus A squared, and all of that over 2BC. So we have all of the values now. So the cos of our angle is going to be 4 squared plus 4 squared, 4 squared plus 4 squared minus A squared. Well, this is A, which is what we've just calculated. 4.226 squared. And then we're going to divide all of that by 2BC. So 2 times 4 times 4. Right, let's put all of this into the calculator. 4 squared. And actually, this was my previous answer from the calculator. So when I get to this bit, I can just type in answer. So 4 squared plus 4 squared minus answer squared. And then in the denominator, 2 times 4 times 4. That should be right. And remember, this is not my angle because this is just the cosine of A. To work out what A is, we just need to take the inverse cosine of this answer. So shift cosine answer, close brackets, and we get, that's a better looking answer, 63.77. 63.7. Let's just down to 3 decimal places, 778 degrees. So now we've got A, we can do exactly the same thing as we did for the red segment. We can do the same for the purple segment. So it's going to be the sector minus the triangle. So the sector, well, that's going to be this angle here, 63.778 over 360, and then times by pi r squared, so times pi times 4 squared. And then the triangle is going to be a half times 4 times 4 times the sine of our angle, and in this case our angle again is 63.778. So to work out the area of the segment, we just need to subtract one from the other. So I'm going to put all of this into the calculator now, and again the 63.778 is stored as my answer. So I can just put let's put brackets in first. So I'm going to put in answer over 360 times pi times 4 squared, close brackets. So that's the area of the sector, and I'm going to subtract the area of the triangle. So 0.5 times 4 times 4 times the sine of answer, because that's still stored at the 63 degrees, and then close brackets. I think I've done everything correctly, and it looks like we get an answer of equals 1.728 centimeters squared. And I think that is right, because it looks like it's similar value to the red segment. So I'm quite happy that that's the right answer. So that is, remember, that's the purple segment. I'm just going to put seg for short. So we've got the red segment and the purple segment. So we just need to add them together now. So it'll be 1.333 plus 1.728. So I'm just going to add on 1.333 and we get 3.061. We need to give our answer correct to 3 significant figures, so that will be 3.06. And we are done. Now we've come to the end of the paper, so hopefully you enjoyed that, and hopefully it will be useful for you with your final maths exam. If you do have any questions, please pop them in the comments and I'll try and get back to you as quickly as possible. So many thanks for watching and good luck in your final exams. Take care.